Hey there. So we're going to continue into the word problems for the combined gas law. And so that's 13 to 24, but you'll notice there's several missing. I took a bunch out of here a long time ago. So we're just going to do 13, 18, 21, 22, 23, and 24. And it shouldn't really take that long. So what I'm going to want to encourage people who are having a hard time setting up these problems is to definitely build a data table. So this is how I want to start. Is I'm going to put down, there goes the dog. I'm going to put down the standard form of the equation for the ideal gas law, which is going to be P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. Once I have the standard form of the equation, then I'm going to build, oops, that's really crooked, isn't it? I'm going to build a data table over here to the right. And I'll just list them. P1, V1, T1, P2, V2, and T2. So once I have that, I'm going to go back to the handout and I'm going to start reading. You might have noticed, and I'm not going to solve these with you, but you can look at them. Let me turn up my light a little bit. That might be a little bit better. Okay, so what I want to show you is a technique that I'm sure some of you who don't want to write data tables are going to find really helpful, is just to label them as you go through. So in this one, I have this one labeled V1, I have this one labeled T1, T2, and V2. So that is a way that you can do it without having to construct a data table. But because some folks I know are struggling with these problems, I want to take and do a data table for you and talk to you about how are you going to decide which is which. So when I read this, I see, I could zoom, I'm afraid of zooming it in because it might make it kind of funny on your screen. A scientist has a sample of gas that was collected several days earlier. The sample has a volume of 392 centimeters cubed at a pressure of 0.987 atmospheres and a temperature of 21 degrees Celsius. On the day the gas that was collected, the temperature, so on the day the gas was collected, the temperature was this and the pressure was this. What volume did the gas have on the day it was collected? So I can see that this, on the day it was collected, these two things and this volume are all connected together. And this and this and this, these three things are all connected together. And I guess if I wanted to be fancy about that, I could use a colored pencil to say these three things are together and these three things are together. And so that helps. Now, once again, it doesn't matter which is one and which is two, which I know can be hard for some people to figure out, but that doesn't matter at all. 1 and 2, because you'll still get the same answer. So you can decide that this is going to be 1 and this is going to be 2, or you can decide that this is going to be 2 and this is going to be 1. It's totally up to you. I just tend to do them in the order that they're typed. Or you could do them in chronological order where this happened first and then this happened second. Let's do it that way. So we're going to say that these, the red ones here are going to be 1 and the green ones will be conditions 2. So I have for P1, I have a pressure, and I need to go back maybe to where we wrote down all the units, because sometimes I noticed that kids have a really tough time deciding which goes where. So if you look for the units, you can see that this is, the unit is atmospheres, ATM, and that is here. You're not gonna find it over here for volume. You're not gonna find it anywhere else. So we know that that unit has to be pressure. And if we're a better reader, we could also see that it says here that the temperature is this and the pressure is that. So that also helps us decide which of these variables we're dealing with. So there are ways that you can get that done. Oh dear, now I've lost my paper. Hello. Oh, there we are. All right, so we've got pressure 1, volume 1, temperature 1. So pressure 1 is going to be the 0.992 atmospheres. Can you see that okay? And then we're being asked what temperature. Okay, so I've got, so volume is my unknown. And temperature 1 is 13 degrees Celsius. So I need to add 273 to that to make it the correct temperature. And that's good. Now pressure 2, 0.97, or sorry, 0.987 atmospheres. And my volume 2 is 392 centimeters cubed. And my temperature 2 will be 21 degrees Celsius, but we want to add, remember, we always want to get that converted into Kelvin when we're doing gas problems. So we'll add 273 to convert our Celsius into Kelvin as a rule. Okay, so now that we have our data table figured out, we can go back to our base equation. And in the base equation, we have to rearrange it to solve for our unknown. And that's going to be the V1. V1 is the thing we don't know that we're solving for. So we need to isolate V1 on this side of the equation and move these two over to this side of the equation. So I'll just start by writing V1 and the equal sign so that I can see that that's what's being left behind. And the P1, T1 need to move over. So that means we need to flip them around and move them to the other side of the equation. So I'm just gonna rewrite these guys because they're not moving at all. So if I just rewrite them, they're in place. And I can draw my line. And then I know that P1's gonna go down here and that T1 is gonna move up. So there we go. Now we have a rearranged equation and I can plug these numbers in and solve. So what will I do? I'll go ahead and give myself a V1 is equal to P2. P2's right here, 0.987 atmospheres. Oops, broke my pencil lid. And then I see V2, 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 V2's 392 centimeters cubed. And T1 is 13 degrees Celsius plus 273. And that is the top. So I'll multiply these together. And on the bottom, I've got T2, which is 21 degrees Celsius plus 273 times P1, which is 0.992 atmospheres. Very good. So let's enter this into our calculators. We're going to get the total for the top, and we'll divide it by the total for the bottom. Yep, we sure will. So let's get our calculators out and multiply across the top. I've got 0.987, and I'll multiply that by 392, and I get 3.86904 times 10 to the 2. And then I'm going to take my 13 and my 273. I'm going to add those together. And then I'm going to multiply that back in. So I get, for the top, the total of the top is 1.1 times 10 to the 5th power. Pretty big number. Along the bottom, I'm going to take my 21 and the 273 and add them together. And then multiply it by the 0.992. And I get 2.91648 times 10 to the 2. So I'll take my top total and my bottom total and divide them together. And I get this for V1 is equal to 3.79 times 10 to the 2. And that's centimeters cubed. So yes, and so that's how we're going to solve these problems. We're going to build data tables if we need to, or we can just label them through on the problem and take the base equation and solve for our unknown, plug in our numbers and solve, and we should be doing really well. Now, some of you are going to start reading, and I'm not sure exactly when it happens, but there's a reference to STP coming up. STP stands for, and you could Google it, it'll tell you what it stands for, but it's standard temperature and pressure. And what that means is that there are some standards that have been assigned for temperature and pressure, and that relates to a standard in volume as well. So when you say a gas is at STP, you're making reference to that gas is going to be at 0 degrees Celsius or 273 Kelvin, they're an equality. And for pressure, you're saying that that gas is at 1 atmosphere. And if you're going to convert that into kilopascals, it's like 101.3. Let me double check that. Yeah, 101.3 K. Anyway, so if you do have a gas and it is at these conditions, it will equal 22.4 liters of volume. So that's important, and it will start becoming an issue at some point. And I wrote it on here because it must have come up somewhere in the words of this paper or the next paper, and I'm just front loading it. But STP, so if there's a reference, it's like you're reading a problem, it says we have a sample of ammonia gas at STP, you know automatically that it is here. It's just like shortcut. You don't have to say, oh, at 1 ATM or at 22.4 liters. If it's at STP, all of these conditions are true. So with that in mind, I'm going to let you work on 18, 21, 22, 23, and 24. If you need help, contact me and I will help you. I am looking forward actually to helping you, and it's something that, you know, I'm thinking will be a fun thing. So contact me and we'll work it out, a way to help each other and get this big, you know, so you can do it. I'm going to give you a couple days to get this done. So you please contact me if you're not getting the right answers. And there's a couple people I've asked to contact me, and I don't have your cell phone numbers, or I would just contact you. So I've also asked you for those so that we can get this figured out, because there are, I mean, a lot of you are getting 100% on everything, but there are a couple people who are struggling, and I really like to talk to you. So there you go. That is today's lesson. after we're done with this, we're moving on to one of my very favorite gas laws, and I'm really looking forward to that. So let's give this a couple days, and I will get back in touch with you. Have fun.